Industry 5.0 represents a new era of industrial evolution where the boundaries between human and machine blur. It puts human centricity at its core, ensuring that technology serves to enhance human capabilities rather than replace them. It focuses on collaboration between humans and intelligent systems, creating a symbiotic relationship that drives efficiency and innovation. Privacy and security are paramount in this interconnected environment, safeguarding sensitive data and maintaining operational integrity. They underpin the trust needed for seamless human-machine interaction, ensuring that both parties can work together without fear of breaches. Failing to address these concerns could have serious consequences, from operational disruptions to loss of sensitive information. Data breaches could expose sensitive information, leading to financial losses and reputational damage. System vulnerabilities could be exploited, making it crucial to identify and mitigate these risks proactively.
This could disrupt operations and erode public trust in Industry 5.0 technologies, hindering their widespread adoption. Therefore, robust security and privacy measures are not just desirable, but essential for the sustainable growth of this new industrial era. Human cyber-physical systems, or HCPSs, are central to Industry 5.0, revolutionizing the way we approach manufacturing and production. They integrate human capabilities with cyber and physical components, creating a seamless blend of human intuition and machine precision. Think of a smart factory where workers, robots, and sensors work in unison, enhancing productivity and efficiency. Safe and reliable machine learning predictions are critical in these systems, ensuring that operations run smoothly and without unexpected interruptions. They enable informed decision-making and efficient operations, allowing for real-time adjustments and optimizations. However, these predictions must be secure and privacy-preserving, safeguarding sensitive information from potential threats. Imagine a scenario where an attacker manipulates a machine learning model in a factory, causing chaos and disruption.
This could lead to faulty products, production downtime, or even accidents, posing significant risks to both safety and productivity. Protecting these predictions from attacks and ensuring data privacy are non-negotiable for the safe and ethical operation of HCPSs, maintaining trust and integrity in industrial environments. Batch verification is a technique used to enhance the security of machine learning predictions. It plays a crucial role in ensuring that the data we rely on is both accurate and trustworthy. It involves verifying the correctness of multiple predictions at once, rather than individually, which can be time-consuming and less efficient. This method allows for a more streamlined and efficient process, ensuring that any discrepancies are quickly identified and addressed. This approach is particularly beneficial for high-criticality predictive systems, HCPSs, where numerous decisions are made in real time, and accuracy is paramount.
By verifying predictions in batches, any malicious tampering with the model's output becomes evident, allowing for immediate corrective actions. This makes it much harder for attackers to manipulate the system without being detected, thereby enhancing overall security. For instance, in our smart factory example, batch verification could ensure that a group of robots are all receiving accurate instructions, maintaining operational integrity. This reduces the risk of coordinated errors or malicious manipulation, ensuring a smooth and secure production process. Homomorphic encryption is a game-changer for data privacy. It allows computations to be performed on encrypted data without needing decryption.
This means sensitive information can remain protected throughout the entire process. Imagine a healthcare scenario where patient data needs to be analyzed for medical research. Homomorphic encryption enables researchers to work with the data. They never access the unencrypted information, ensuring patient privacy. This method increases efficiency by 15%. Led by Prof. Chang, this technique has the potential to revolutionize various industries. It enables secure collaboration and data analysis without compromising privacy. Please click like, and subscribe. Thanks for watching.